Okay, all right, perfect. So here's what we're doing today. We're just going to introduce what our next section is. That's what I always want to do. I like to do a light introduction. We're going to do a 2-day light introduction because I don't really want to start anything hot and heavy and new because some people are still taking tests and I don't want to have them lose out on some of the material. So I just want to just briefly introduce what we're doing. We've been talking about parabolas. That's, quadratics, polynomials. That's what we've been doing those last, 2 units, really. We've been graphing, doing all the parts of them. We're getting into the more detailed stuff now. So the next section we're going into is called Conic Sections. This is a major topic. It's something that I know for a fact that you cover in Algebra 2. But it's nice to see the stuff that I need you to be able to do with it. So that's what we're going to look at today. So I'm going to be mixing a couple different topics today, but not conic, but conic sections. Conic, there we go. But let's actually talk about what a conic section is. A conic section is a part of a cone. So if you don't know what a cone is, here's a very rough diagram of a cone. Okay, like an ice cream cone, right? Well, when you take like pieces of it, like slices of a cone, you get all the different types of conics. So, like for instance, if you were to look at the cone as it sits right now, like at this weird angle, what does the top look like to you right now as it sits? Right here, what does that look like? Say it. It's an oval, right? They call that an ellipse. So an oval or an ellipse. That's one of the pieces we're going to look at, right? It is a type of conic. It's just this, it's based on a circle. Conic is, all based on, circular curved edges. Well, an oval or an ellipse is one of the mathematical things we're going to look at. We're going to look at the formula, know how to graph it, look at the pieces of it, what's important, all that good stuff. How do they design it in the first place? You'll see like a really hands-on approach to doing that. So that's one of our first topics we're going to talk about. That's, I think, maybe section 2. Section 2 is ovals. Now, if you were to look straight down on top of the cone, so let me draw it in a different format. If I were to look straight down on top of the cone, like this, what does it look like? A circle. That's looking straight down, top down, like looking inside this cone. Well, that would be a circle. That's a part of a conic. So it's and this is the weird thing. If you were to take like a penny, a coin, any type really, a quarter, okay, and you were to take it and look at it at a different angle, like really hold it like close to your face at a kind of an angle, not straight on, but at a weird like tilted, it will look like an oval. It's a matter of perspective. And so that's a type of conic. You can see it. You can probably do it at home if you have a coin right in front of you. You can see that idea if you were to tilt it. We'll look at the formula for a circle and how it's related to an oval or an ellipse. We'll compare them. Now, the other types of pieces, and these are the ones that are a little more challenging. If you were to take a cone, and so this is going to be the tough part. In fact, let me erase the cone that I currently have. Oh, actually, I better take a screenshot of that before I... Whoa! There we go. Before I start erasing. All right. So, if you were to take that same cone that I just did a little bit ago, here's my cone, okay, and you were to take a slice of it, not at the top, but maybe off to the side, like this, at a kind of a weird angle, like imagine you took a bite out of the cone, right? You took an actual bite, your mouth would represent a plane, and you cut it. Well, what the cone would look like, if you were to look straight at the cone, it would look like this. Agreed? That's what it looked like. The cutout here, this part that's missing, this little shaded edge right here, that part that's gone, is not the actual shape of your mouth. And that's the part that really weirds people out. It's the simple fact that you had a flat surface cut a cone, and it would actually make that indent. That's a parabola. That's actually what we did in the last section. A parabola is a type of curve, right? It's got a lowest point. It's got, it's got some upper points. It even has vertices and all that good stuff. So that's something that that a lot of people don't realize, that a parabola is actually made from a cone. Okay, and then there's another thing called a hyperbola. So let me take a screenshot of that. And the last type is a hyperbola. And a hyperbola is where you take two cones. So here's a cone. And imagine you had the same exact cone going the other way. So they're attached. Attached perfectly, like a perfect bow tie almost, right? And you were to take a cut out of both. That would be a hyperbola. Hyperbola would have two curved edges on both cones. It'd look like the parabola, but there'd be one on the top, one on the bottom. And that would be a hyperbola. There'd be two of them, top and bottom. So those are all the different pieces we're going to be looking at. In fact, let me write down the word hyperbola. Now, the main difference between a hyperbola and a parabola is typically on one of the cones, not the other cone. So how you get that cut is you tilt this like flat edge more. So you would actually tilt that cut like this instead. And that's what would give you the parabola. It'd be more pronounced, as opposed to going straight up and down, being like perpendicular with the cones. You go at a weird angle. So that's why a parabola and a hyperbola are different. So that'll be the difference in drawings. All right. Okay, questions currently on the different types of conics. Okay, maybe you don't know the details of them yet. That's what we're going to get in this section, so don't feel like you need to be lost. I just want you to get a sense for the drawings. Now, what I want to talk about today is kind of mixing some of the stuff we've done previously with some of the new stuff coming up, right? So this is where the difficulty comes in. This is where the difference between pre-calc and algebra 2 comes in, where what are we going to do with this stuff? Other than just look at it, look at the formulas. We're going to do some complicated stuff in here. And this stuff I want you to look at. Like for instance, one of the things I want to discuss is, can we find what they call the point or points of intersection? So what I mean by that is, if we look at two objects, so let's say we looked at a quadratic, a parabola, and you looked at a linear function. Could we find where they cross? Because eventually on a drawing, they would potentially hit, and I say they don't have to, they could potentially hit. That's what I want to discuss. So, for instance, let's do an example here. So if you have your notes, this will be our one note of the day. So, for those who are testing, keep testing, you're fine. We'll review a little bit tomorrow on this. All right, so let's take a look at an example here. So let's say the parabola that I want to do, let's go with like x squared plus 8x, and let's go with minus 9. Okay. That's odd. Pencil suddenly stopped working. That's really odd. So what you're looking at there, that's a parabola, and then a linear function. Let's go with like 3x plus 1. Let's do something like that. It's really odd. Why did that stop working? It's not dead. Is it? I'll charge for a couple minutes here. All right. And what we're going to do is we're going to look at could we find a point of intersection? So this is just kind of a rough introduction. So how you actually do this, number one, you could draw both, right? Physically draw them and kind of see where it's going. And that's something I want you to see here. I want you to see like the actual drawings, and why do we do all the stuff that we previously have done, right? Like, why do we talk about where the tails go? Like that was a point of the 7-step method in the previous test we did. Where the tails go, where are the intercepts, that type of thing. Like, why do we get so detailed? That's something I want you to know. So, for instance, on this particular graph, if we look at the top one, I'll put the top one maybe in, we'll put the top one in green here, so this will be in green. Where would the tails go in this particular problem? Up, down, right, left, where are they going? Up, right? Because it's a power 2, right? They typically will go up. It's a positive x squared. We could factor it apart to figure out where the x-intercepts are. So how you factor this. It'll be, what, x and x. It'll be a plus and minus. Because the minus sign in the back tells me it's plus minus. And then we have to break it up to go like 9 and 1. 9 and 1, like that. And so, so it's x plus 9 and x minus 1. So where would the two x-intercepts be? What is the number that represents x plus 9? So x plus 9, what would that represent? What do you guys think? So this parenthesis right here, right? This parenthesis was x plus 9. Why can I not write a plus? What would be the coordinate that would represent that? -9, okay. -9, and what would be the x minus 1? 1, right? Positive 1. So I would draw -9. -9 is about right there. And positive 1 is about right there. And there we go. And then the y-intercept on this particular graph, you look at the number in the back, you plug in zeros for all your x's to figure out y-intercepts. So I hit it -9 all the way down here. And so I can get a sense for this graph is going. It's doing something like this, right? Let me make that line a little bit thicker. So it looks a little bit better with my finger. Oh yeah, there we go. There we go. Way better. All right, so there's my graph, right? That's the top one. I'm supposed to draw that in green. We'll go with blue. All right, now the other one. This is a linear function. So we're going to draw the linear function here we'll draw this linear function with the idea that it's just linear. We start at a y-intercept. It uses slope. We go from there. So, but again, let me draw this. So this one would start at +1, and then the slope tells me to rise 3, run 1, rise 3, run 1, and I could draw that line. And so, how many times would these graphs cross each other? 2, right? There'd be one up there, there'd be one down here, right? Does that make sense? Well, what we're doing in this section is not only just, figure out formulas and figure out how to graph things, it's also to figure out how to find these answers in a more efficient way. Drawing's fine. Like, you can see my drawing I drew with my finger, it's terrible. But I want you to figure out the best ways to do this stuff. Not just the first way, like this way, graphing, because it's not great. But I want you to figure out a more efficient way to do it. And that's what we're going to be looking at these next couple days here. So yeah, so that's kind of the concept here. Okay. Questions on what our kind of our goals are for the next few weeks in here. Okay, so I know that's a really rough introduction today. Google question of the day kind of gives you this idea of I give you a problem like this, like I just did, and I'll ask you roughly where you think they cross. So if I was doing this and maybe I was drawing this on paper, I would say that it looks like it's crossing at like 1, 4 and -5, -7. I'm just kind of guessing, and how I did it by drawing. That's kind of the idea, and I want you to kind of explain that. So it's kind of going back to your old school roots. It's nothing new in the Google question stuff we've done previously. So that's Google question of the day, and I want everyone, even the people online, to fill that out. So, all right, tomorrow we'll go more in depth. Maybe I'll start showing you a different way to do this same problem, but that's it tomorrow. I'm going to do it. It's going to be short and simple and to the point tomorrow. Okay, so I might even have a very similar type of question tomorrow, so that way you can see that there's better ways to do it than just drawing. So, All right, that's it for today. So if you're online, you can log off, go fill out your Google question of the day, and you're done for the day. So pretty easy. I said it was going to be short and sweet and to the point today.